Okay, here we have a plane flying in a certain direction at 600 miles an hour. And then we have a wind blowing in a different direction at 80 miles an hour. What is the resultant speed? Because your wind is going to have an effect on your plane. Well, for the most part, we have our wind going at a 45-degree angle because if you are going north for your wind and rotating 45 degrees in the eastward direction, that's really 45 degrees from standard position. Your plane, is going 600 miles an hour, really at a minus 30 because it says south 60 degrees east. So you go south, rotate 60 degrees in the eastward direction. So that means this angle right here is 60. So that means you're 30 below the axis, or negative 30. We want to find the resultant speed. In other words, if I were to take my wind vector, slide it down here to the end of my plane vector, my resultant would be what we have right here, going from the very beginning to the very end. So I'd be looking for the length and direction of the blue. Is for the most part what we're looking for. But we're going to start off by finding the component form of each one. So let's look at our wind. We want to figure out this horizontal side right here, which is x. You know your hypotenuse is 80. So that's cosine because it's adjacent in hypotenuse. So you go cosine of your angle equals adjacent over hypotenuse, and you get the horizontal component of your wind to be 56 something. So when you're writing it in standard form, you're going to put that number here to begin with. Now, if we're looking for this part right here, the vertical, that's like your y going up and down. Well, that's an opposite of your angle and your hypotenuse, so that's a sine. So sine of your angle equals opposite over hypotenuse. So then we get 56 something, which we would then put here. Well, it would make sense that both of these are the same because it's a 45, 45, 90 right triangle. We want to do the same approach for our wind, our plane. So here's our plane. We're looking for the purple horizontal here, which is adjacent to your angle and your hypotenuse, So once again, that's cosine. Cosine of negative 30 equals your adjacent purple over your hypotenuse, and then we get this. So your plane is going really 519.6 miles an hour to the right. And now we need to go ahead and figure out the vertical, which is the light green, going up and down. So that's opposite. So we use sine of our angle equals opposite over hypotenuse. And then we get this for our angle, or our opposite side. So we know we have this. Well, what you really want to do then is you want to take your wind vector and add it together to your plane vector. So in other words, you want to add the two x's together because adding vectors only works in the rectangular form. It does not work in the direction form. So then we get this. And then you want to add your two y's together. This number here, to get this one down here. Well, that tells us our plane is going at this rate to the right and this rate down south. Well, once again, we're looking for the length of the gray and the direction of the gray. Well, if we know our two sides of a right triangle, we can always figure out the hypotenuse by using the Pythagorean theorem. This side squared plus this side squared equals the square root of this side squared, or equals this side squared, so you got to take your square root. And so we get our length of our gray to be approximately 125.5 miles an hour. But we also want to figure out our angle. So we want to figure out this angle here. Well, once again, you have your angle, you have your opposite, you have your adjacent, so that's going to be tangent. So you go tangent of your angle equals your opposite over your adjacent, and then you'll have to do your tangent inverse to be able to finish solving it. When you type that into your calculator, you would get negative 22.9 degrees. So this is negative 22.9 degrees down. But we started out with a problem dealing with bearings, which always tells you how far you are from the north-south line. So here's your south. How far do we have to rotate to get to this? It's really just 90 plus our negative angle here. So we would say our direction is south, 67.1 degrees east.